our worksheet. All right, so there's the first one. Let's look at the second one. So when we look at the second example here, B, we don't have that clear picture by comparing the triangles same side. So look at this bottom side of each triangle. So first off, the symbols show us that they are similar. And then when we compare 12 and 20, 12 doesn't really go into 20. I mean, you can use it as kind of an estimate. 20 is a little less than twice as much as 12. So, I mean, it is going to follow that rule. 15 is going to be a little less than twice as much B. But if it doesn't go evenly, I say let's just stick to a proportion, okay? So go ahead and pause your screen, work this one out, set up a proportion, cross multiply and divide, okay? Go ahead and do that. All right, so let's take a look at the proportion you should probably set up here. Again, we're trying to find this side. So we're going to start here. All right, we're going to make a proportion, start with probably B over 12. You could put 12 over B. Doesn't matter, because what matters is that this next step, we correctly identify the same sides. So we're looking at B, we need to go to the other triangle and find the same side as B, which would be a 15. The same side as the 12 in the other triangle is a 20. So here's your proportion. Cross multiply and divide. Cross multiply. 12 times 15 is 180. Divide by the number you haven't used. 180 divided by 20, same as 18 divided by 2, which is 9. All right, so that would be a 9, okay? Which, if you remember, 15 is a little less than twice as much. 9. Twice 9 is 18, so 15 is a little less than twice 9. All right. Not going to go through all these. Number 4, you look at number 4, you're going to see some problems like this, possibly on the test. And the first question is, are these two triangles similar? So think about that for a second. Pause the video, decide, do you think those triangles are similar? Or why or why not? One triangle is part of the other. Do they have the same angles? All right. So they only give us one angle, which is the right angle. Notice this angle is the same for both. It's the same actual angle. It's for the small one, but it's also for the big one. And so we know that angle is the same for both triangles. We also know they both have a 90-degree angle. Therefore, they both have two of the same angles, which means this third angle has to be the same. So the question to, are they similar, is yes, they are similar. They have the three same angles. Now, when you're doing a problem like this, there's really kind of some ways that you can be tricked. And so my suggestion is take a little extra time, 20 extra seconds, draw them separately, okay? Draw them separately and label them, all right? So I'm going to do that real quick and kind of show you what I mean. I'm going to keep my big triangle. I'm just going to redraw this small one maybe underneath. Okay. Let's get these letters. P, R, T, S, and Q. So then this one would be R, S, T. Okay. If you want, you can even take this out. Okay. So first question is, are they similar? Yes. What is the length of QT? What is the length of QT? So notice QT, they want to know what is this length. So we have 3 and 4 in this bottom triangle, these two sides, and in the top triangle we have 9. Now remember, you can look and see if one triangle is an even number of times bigger than the other by comparing the same sides. So notice this side is 9 and this side is 3. 9 is exactly 3 times more than 3. Okay, so if you can see that, apply that rule to every side. That means this side is going to be 3 times more than 4. 3 times more than 4 would be 12. Okay, technically the proportion for it, I don't remember if that was an A or what it was, but we'll call it an A. If we're going to write a proportion, start with the triangle we don't know, A over 9. Okay, and match. What's the same as A in the other triangle would be 4. The same as the 9 in the other triangle would be 3. Cross multiply, divide. 9 times 4 is 36. Divide by the number that's left. 36 divided by 3 is 12. All right, so it works. As long as you set the proportion up correctly, it's going to work every time. But if you can save yourself a little bit of time and see automatically how big one triangle, how much bigger one triangle is than the other, how many times bigger, then by all means, do it that way. Number 5 is another example of one that you might see. Actually, it's kind of the same thing. It's just a real, like a world, a real world or a word problem that is the exact same idea as this last problem, where one triangle is part of another. The sun's rays hit the top of the tree and the top of the person the same way and creates a shadow. So the angle between the person and the tree at the top is the same. We also know the angle of the tree and the ground is 90 degrees because trees grow straight up, and this girl is standing straight up as well. So she's standing at 90 degrees. They are similar, and therefore you need to use the idea of similar triangles to solve it. So let's do this one real quick. Tanya is 1.3 meters tall. She stands 7 meters in front of a tree and casts a shadow 1.8 meters long. How tall is the tree? Okay, as I've said, draw pictures, okay? Make the problem make sense. Don't spend a bunch of time on it though. Just enough to make it make sense. All right, so she is 1.3 meters tall. She stands 7 meters in front of a tree. And her shadow is 1.8 meters long. Question is, how tall is the tree? All right, let me show you my picture. Okay, hopefully you can see that. She is 7 meters in front of the tree. She is 1.3 meters tall. Her shadow is 1.8 meters. The question is how tall is the tree? Okay, and so we need to see that these are similar triangles. And maybe like I told you to do on that last problem, go ahead and break them apart. Maybe when you break them apart, go ahead and actually draw the triangles. So this is the small one. She's 1.3 tall. She has a shadow of 1.8. And then the larger one, we don't know the height of the tree. The shadow of the tree is going to be the 7 plus the 1.8. That's kind of the trick to this problem. So therefore 8.8. Okay, now we're going to set up our proportion. Start with the triangle that we don't know. Let's change that question mark to an x. So x over 8.8 is equal to, now we got to match. X is the same as the 1.3, so they go next to each other. The 1.8 goes with the 8.8. Cross multiply and divide. Feel free to use your calculator. I'm going to. 8.8 times 1.3 is 11.44 divided by 1.8, 6.3555, so we'll call it 6.36. Okay? So the tree (6.36 meters tall. Hopefully that makes sense. That one can be a little bit tricky. Whenever there's a triangle within a triangle, it's best to separate it. And you know what? You got to draw a picture to make sense of the problem.